Hey everybody, hope you're all doing great today on Sunday. My name is Raghav Sani and I'm the Director of Experience for HackThis 2020. Mega, do you want to introduce yourself?
Yeah, hey everyone. My name is Mega. I'm one of the co-directors for Hack Illinois and this event, and we're really excited to be here. We're here with Arya, who is going to host a workshop, Introduction to Web Development Part 2, regarding GraphQL. So Arya, we'll let you take it from here.
Hi everyone. I'm going to share screen. That's it. Cool. So you guys should be able to see my screen. Yeah, so this is an introduction to web development for GraphQL. So I'm Arya. I graduated from UIUC in 2019 spring, and I currently work as a software engineer at Samsara. I work on the cloud infrastructure team, so focusing a lot on performance, scalability, and GraphQL. And I go by @codebrew28 on most GitHub and other social media. And my username may or may not represent my obsession with cold brew. But yeah, so just a brief overview of this talk. So we're going to start with the client server model of how it is from web development, and then go into what GraphQL is, go into a live demo of a server and a client and how does it work, and then talk a little bit about the scalability of it. So yeah, let's get started. So I like to think of the client server model as a client server in a database. And I like to think of it in terms of a restaurant. So a client is like the one getting food, sitting at the table. Your server is the one giving you food, and your database is your pantry full of fresh fruits and vegetables or things that you're going to put in your food. And so your client is going to request food from your server and say, hey, I want like a pasta. Your server is going to go ask your chef to make the food, which is similar to like a server getting it from the database. And then your database is going to get food your chef is going to make the food and give the server the food. And then your server gives the food back to the client. And so thinking about it with this model, one of the most interesting questions is how can a client precisely ask what food they want? So if the customer wants a pasta, they don't want all the pastas. They want to be able to say like, hey, I want the spaghetti pasta or pesto pasta, and I want cheese or I want no cheese, and to like precisely say this is what you want. And that's very similar to one of the problems you deal with web dev from the client. How do you specifically tell the server, hey, this is the information I want, and I want just this piece of information? And so this is where we hear about REST APIs and GraphQL. So I'm going to start with REST APIs. And so in a REST API, you have an endpoint where you have a link to like an endpoint saying like, so Swappy is the Star Wars API, and you can say /people/1, which will specify like this is an endpoint you're hitting for information about the person, and you want the person with ID 1. You can specify a method. So get is when you want to fetch data, post is when you want to like add a new user or like change the data, delete is like if you want to delete a user, you can delete the data, and so on and so forth. You can specify headers. So this is where you can put like an auth token in to say like, hey, I need this authorization so that not anyone can go query my server, only my client can. And that's necessary for security. And then the response you receive is structured like JSON. And so the best way to show you what a REST API looks like is to just go to one and use it. So this is the Star Wars API. And so if I go there, I can go to Sloppy Dev API, and if I use Starships 1 and I request it, I can get information on the first starship. If I go to People 1, I can go get information about Luke Skywalker. And if I change it to People 3, I can go get R2-D2. And so through this endpoint, you're able to query different amounts of data and specify what you want from your server. So going back to the presentation, so that's what a REST API is. And so what GraphQL does is it goes the step after and says, instead of exposing all these endpoints, you're going to expose a single endpoint called /GraphQL, which takes in a query and returns the data as JSON. So I'm going to go through an example to explain this a little better. But GraphQL is just a query language to say like, how do I specify what data I want from my backend? And this is a relatively new framework. It was released by Facebook in 2015, so it's only been around a few years, but it's gained a lot of popularity. So this is what a GraphQL query would look like, where you have an input and you specify you have a user, and you specify ID1. And start saying, I want the user with my ID1, and I want to get the ID and the name. And so if this is your query that's being sent in the request, your output is going to mimic the same format. So you're going to have user in quotes, and then for your user, you're going to go get the ID and the name, and you're going to fill this in with information. So ID is an int, and name is like a string. And then you can precisely tell it what fields you want. So if you no longer want the name, if you remove it from your query, you're no longer going to get it in your output. And so this is a way to specifically say like, hey, I just want these fields. And so why is this useful? So with REST APIs, we often run into the issue where we're sending too much data. So if you remember on when we went to swap people.3, like we're requesting getting all these fields. And let's say the client goes and hits this endpoint, but it only cares about the name. It doesn't need to show the rest of the information. But we end up wasting a lot of bandwidth getting all the data and spending time fetching it when we're not even showing it to our users. And so that's kind of one of the issues REST APIs deal with, where you have these general endpoints that give you far more information than you need. And then when you want to kind of work around it, some people would say like, hey, let's go create specific endpoints for just the fields I need. So you can say API/people name if I want just that person's name, or ID and name if I want the ID and name. And so this works, but you end up creating a lot of very specific endpoints to get specific pieces of information. And so as your code base scales and you get a lot of endpoints, it becomes difficult to manage, to know what exists and what doesn't. And that's kind of where GraphQL came in. Of it saw this need of like, we want an efficient way to query information. And we're like, let's build something around with those specifications in mind. So how does one actually use it? So GraphQL itself is just a spec. It's the query language, but we want to find a framework that actually uses it. So a couple of the big ones are Apollo, which is the one I'm going to do a live demo in. It's in JavaScript. There's Relay, which is one that was directly released by Facebook and also in JavaScript. And then there's Thunder, which is one in Golang, which is released by Samsara. So a little biased because this is the one I work on, but yeah, I figured I'd mention it. But yeah, so I'm going to pause if there are any questions right off the bat, and then we're going to jump into the live demo. Mega?
Yes.
Are there any questions, or should I keep going?
Yeah, you're good for now. Yeah, keep going.
Cool.
Awesome.
So if you go to that link over there, you can see the live demo, but I'm just going to show it on my screen and kind of go through it. So close that again. So when I look at my code base, the first thing I want to do is create a GraphQL server. And so the bare minimum to get it set up is I want to create this package.json. And so I created these steps 1 through 6, which each like are independent GraphQL servers with everything they need, but each one shows a different thing. So you can run each one separately. And then you want to add all your dependencies. The really important ones are like Apollo Server Express, which is a node library that allows you to like specify what you need to make this GraphQL server work. So we're just going to go to step 1.js, and this is this entire file is your entire GraphQL server. And so key things you want to do is you want to go import Apollo server, you want to start it up, and then you have two things. You have a schema and a set of resolvers. And together they're going to form your GraphQL API. So in GraphQL, you have two types, two like sensitive things. You have queries and mutations. Queries are anytime you fetch data, and mutations are anytime you change data. So we're going to go through a bunch of queries first. And in this case, we want to query a field. And so in your schema, we always start with these two types of query mutation. So we can say type query, and then we can specify fields on it that are like root level things that we can get. And in this case, we want to specify a field called attendee that will give us back a string. And so our resolver needs to match the exact format of it. So in a resolver, you can say I have a query, and then I'm going to resolve attendee. And attendee isn't going to take any args, but it's going to return a string called John. And so what it does is tells it like, hey, when you reach attendee, this is how you resolve that field to get information. And then when you create your Apollo server, you give it your schema and your resolvers. And then you tell it, I want to expose it on the /GraphQL endpoint on port 8000. And so if you go to this link, you'll start up your GraphQL server. So to kind of start this up, I'm going to be in my server. I'm going to run npm install. This will install any libraries that I need to use. And I can run npm run step 1. And that will just run this file. So if I go over here and I go to my playground, so when I go to localhost 8000 /GraphQL, this is an interface like a UI built in for your GraphQL servers that's automatically provided by Apollo. And so you can specify queries in here and run them to get the results. And so in this case, I created a field called attendee. And so when I specify 2 quotes, 2 brackets, I can say, hey, this is my query, and I can write attendee over there. It does autofill it, which is really nice. And when I run it, I'm going to get my response. And so my response is structured it's nested on data. And then this structure matches the structure of the query. So it's going to match attendee, and it's going to resolve to John. And so a couple really nice things about this interface is you have a set of docs. So any field that you add, it's automatically going to generate these docs telling you what type it resolves to, and let you see the entire schema, which is just nice if you have like a new GraphQL server, you're trying to see what's there. It's really nice to just be able to pull up the docs and learn what you can query. Yeah, so this is step 1, where we just create a field and we have it resolved to a string. So let's go on to step 2. So in step 2, we want to go and create an object. Zoom in a little bit. So in this case, we want to create an attendee object with a set of nested fields. And so we want to be able to say, hey, an attendee can have an ID and a name, and we want someone to be able to query it. So we have a similar structure. We have a type query with a field called attendee, and we tell it returns its attendee type. And so if this was a string or an int or a boolean, those are called scalars, and they can resolve. When we see attendee, GraphQL says, hey, I don't know what this type is, but someone may register this type. And so when you say type attendee, you're registering this type and specifying what fields can exist on this object. So you can have ID in your name. So ID is a special Apollo ID, which says that this is just a unique int, which can get used in other ways, but we can just treat it like an int. And so similarly, in this case, we want to create a resolver for attendee that doesn't take any arguments, and it returns a struct in this case. And the struct has an ID and a name, and so this matches the pattern of an attendee. So it says, okay, this is my attendee that I want to look into, and query. And similarly, you go set up your Apollo server and you query it. So if I go over here, I can start up the server by saying npm run step 2 and go to localhost 8000. And when I go to attendee, this is not going to work because it's expecting an object type. But if I go in further and I specify, hey, I want the ID from it, it's going to tell me my ID is 1. If I want to specify the name, I can go get that extra field and so on. If I specify a field that it doesn't know about, it's going to tell me, hey, this isn't a field, you can't query it. Yeah. So this is how we create an object. And so the next thing we want to learn how to do is how do we make a query that actually has arguments? So if you go back to this example, we can go to step 3, and we have the same setup. And then in this case, attendees, if you put in parentheses, you can specify like, hey, this is an argument. The first one is your name of your argument, and the second one is the expected type. And so I'm expecting an ID, and this should map to an attendee, and it should give me back a single attendee with ID name. And so I'm also going to go ahead and create a list of attendees in which I have 2 attendees, John and Bob. And in my resolvers, one of the cool things I can do is I can now actually use these args. And so the second field is our arguments. And by providing these brackets and like a value, you can parse it and say, hey, give me this ID from it, which will get whatever we pass into here and go to all attendees and search for that ID and return it. So let's actually run this and see how it works. So I'm going to run step 3. And then when I come back here, this doesn't work because it needs an argument specified inside. So I want to say ID 1. I called it attendees. So for attendees, I can specify ID 1, which will get me John. And if I specify 2, it's going to go get me Bob. And then if I specify 3, this is one that doesn't exist. And so it's going to yell at me and say, hey, I can't return null for non-nullable fields. And so what this actually refers to is when I said attendee, I put an exclamation mark after. And so when I do that, I tell my GraphQL server, hey, I'm promising this resolver will give you back an object. And so if I remove this and restart my server and I pass in ID 3, it'll just fill in null in that value if it doesn't actually map to anything. But when you press exclamation mark, you're guaranteeing that it's going to exist. One other interesting thing to note about this example is right now we have parent, like we're passing in these arguments. And so we're right now only using args, but there are other arguments we're passing in. And so I'm not going to go through examples with this, but I'm going to kind of show you in documentation what it is. So these are the official Apollo GraphQL docs in which you have your parent, you have arguments, context, and info. And these are the 4 arguments you can specify to pass into any resolver. And if you learn more about them, you can kind of see what they're meant to be. So a parent tends to tell you like, from the step above, like what is that return value? So if I had a query that looked like, I don't know, like mates or something that returned another nested object, this teammate value, like its parent would be attendee. And so it passes information about where it came from, which like can be useful if you want to see like if that changes how it resolves the field. Arguments are anything provided in like the parentheses to that field. And so in this case, like this is an example that uses ID similar to our case, but you can pass in anything you want. You can pass in strings, objects, kind of whatever you need to. And then the third argument is context. So if you have like any authentication information or things that you want to share between every single resolver, you can put it in the context, and that context will be shared and passed into every single one. So the example they gave is like authentication information or data loader instances where you can store that information there. And the last one is info, which is information about like where in the query you are and like the full query, who are the parent fields and so on. Yeah, and this is used for things like caching. We can explore these use cases a lot more, but the only one I'm going to dive into is args, since that's the most commonly used one. And so, yeah, it's just a bit of clarity to be like, how does this ID come through and what is it used for? Yeah, so that's step 3. Let's jump into step 4. So step 4 is an extension on this where we want to say, hey, we want to return a list of items. We don't want to return a single object, and we want to go fetch this. So if we set up a query that says, hey, I want all attendees and all their names, I should be able to get the full list. So in this case, you have a query of all attendees, and when we wrap it in brackets, we say, hey, we're returning a list. And when we do attendee exclamation mark, we're saying like, hey, there are no null values in this list. And then your type attendee is the same. And so in your resolvers for all attendees, you're going to run object.values. So what this is doing is saying all attendees is a map from ID to values, and object.values will just get all these values. So like ID1 and ID2 and put them in a list. So you can get your list of all your attendees and return them to your user. And so similarly, you do the same setup for your server and you run it. So we're going to start with my server. And in this case, you can kind of look at the docs. So yeah, and it's lagging a little bit, but if I say all attendees and I say ID, what it's going to go get me is the list in brackets, and then every attendee with just the ID information. We can also add name information, and we can see more data about it. So once you've gone on the list, we can jump into step 5. So step 5 is saying like objects can return objects. So this is our way of saying we can have data that's nested to represent more complex data structures, and we can nest this as much as we want and with as many objects as we want. So in this case, an attendee can have a teammate that is another attendee. So yeah, let's look at the schema model for this. So in this case, we have a type query to get all attendees, and our attendee has an ID name, but now it also has a teammate, and teammate maps to a list of attendees. So this can be like the same object and say, hey, I want to get a list of objects. And so when we go to these resolvers, we kind of match it. So all attendees is the same thing as just getting object.values, but when it like resolves the attendee, right now it's just returning like these consts, and these consts only have ID and name specified. So it doesn't have a teammate specified. And so what we want to do is, in addition to query, create another object called attendee and specify teammates. And when we do it over here, we specify that like, given an attendee with just this ID and name, we can go and do some extra computation to resolve that field and get it like an answer. And so the cool thing about this is oftentimes you can think about it as like your ID and name are fields on your database. You're just fetching them from the database. When you resolve teammates, it's an extra layer saying, hey, I want to do some extra computation and provide the abstraction level called teammates to go resolve it. So this might make sense when I walk through an example a bit more. So what we're going to do is call object.values of all attendees. So it's going to get this list of every single one, and then you're going to run a dot filter. And so this is like a for loop that will go through every single element, and we're going to call them a teammate, and we're going to check whether that teammate's ID is equal to this attendee's ID. And attendee is an argument passed from above from like the step before. So in this case, it's going to be passed like this. If it's past this first object, it's going to look through all attendees and say, hey, my John is me, like we have the same ID, so I'm not going to include it. But for Bob, like this is ID2, it's a different user, so I'm going to make this person a teammate. And so that's what this logic is doing, where it's basically saying you're teammates with everyone but yourself, because it wouldn't because it would make sense to like be teammates with other people on your team. And so in this example, when we run it, we can run npm run step 5. We can go to all attendees and get the ID name, same as last time, and then we can specify teammates. And I specifically want to show this error if teammates is an attendee, so you do need to specify what fields on it you want. And you can say, hey, I just want the ID. And we have a working, so we have Don's ID, and this teammate has ID2, and then ID2 is teammates with ID1. So, okay, they're each other's teammates. And so this is kind of an example of like how you can nest objects on each other and kind of cater your query to match whatever that client needs and the relationships between like you want your attendees and your teammates, and you want to mimic these relationships, and you want your queries to intuitively match like the data and what the page shows. So yeah, so that's step 5. So step 6.
We have a couple of questions. So the first one is, how would I associate a picture with a certain user in a database without storing it locally?
Yeah, so you would want to have another service that's hosting your picture. It's kind of like, I think you'd use a CDN, which would basically like host your picture, and then you can just link to it and it'll bring it in. There should be a couple examples in Apollo documentation if that helps more.
Awesome, thanks. And then another question is, where do you assign attendee to be a class of ID and name in the resolving step?
Yeah, so wait, can you say that again?
Yeah, sorry. Where do you assign attendee to be a class of ID and name in the resolving step?
Yeah, so it's not really enforced in Apollo the way it is right now. So I can specify type attendee, and like this tells my GraphQL framework that like I'm expecting these two fields, but there's nothing to really enforce it over here. But generally, like if you provide fields that it's not expecting, when you run that query, it's going to error out at you. And then, yeah. I think there might be logic to enforce like, hey, this is an expected type that looks like that, but JavaScript doesn't enforce you to specify that exact type.
Awesome. And then another question is, sorry if this is a little bit outside the scope of this workshop, but could you talk a little bit about API keys? Possibly if they're utilized with this framework.
Yeah, so I think so with AP, so I think in this case, we're talking about authentication layers of like, how do we, from the client to the server, how do we specify like, this is coming from the client? And so what you can do is have it pass through the context. So, so this is like one of the 4 arguments. So we were talking about args. So one of the arguments can be context, and you can specify like authentication information. So you can pass in like a key that says like, hey, I want to like check whether I have permission to actually see this data. That's one way to do it. Another way might be when you initially get the request, you can insert some middleware that says, hey, I'm going to go validate my token before running this request. There are a couple libraries to actually help you out with this, but I'm like not going to do examples of it.
Perfect. And the last question we'll take right now is, does this work with TypeScript?
Yeah. Apollo should have support for it. You can look through their documentation for it.
Awesome.
Cool. Was that it for now?
Yeah.
Awesome. Okay. So we're going to go through one more example for things we can add on our server. And the last one is mutations. So mutations allow us to change data. So this example, we have a mutation called M, where we want to add an attendee, and we can pass in a name. So I'm going to pass in a string, and I'm going to get my ID and name out of it. And so similarly to the way I was specifying like type query, you can specify type mutation and add your field called add attendee. You can specify name with a string and return your full object. And so the resolver for this looks like similarly the way we query, we're going to add a mutation. We're going to say add attendee, and this is going to take a bunch of information. So this argument is going to take the name, and you're going to create an attendee with your ID and your name. Your ID is set to 3 over here. This is just something I hard-coded for this example. And then after adding every attendee, you're just going to update this counter by 1. So the next ID will have a unique 1. And you're going to add it to your list of all attendees and return it. So yeah, so this is how you define the mutation add an attendee. And then since this is mutating this list of all attendees, as you query all attendees, your data is actually going to change. So yeah, so let's run this and see an example. So let's go back to our playground. In this case, we're going to add an attendee. So let me that field. We can specify the name passed in. So I'm going to say Aria. And then this is going to return me back an attendee object. So I do need to specify which fields I want from it. So I can just say ID and name. When I run this, oh. Did I spell it? Okay. So the reason this is actually erroring out is because when I didn't specify that it's a mutation up top. So I need to say mutation and then give it that mutation name. So I'm going to say adding an attendee. And then it's going to go and add 3. And I can add another one of like, and it's going to go create another attendee 4. And then when I go query all attendees again, and I specify ID and name, we're going to see that our data actually changed. So we now have all 4 users, and that's because this data is being stored in memory in the struct. But ideally, like when I close this server and I restart it, this information is not going to be saved. So instead of persisting it here, you want to persist it in a database or somewhere that will like hold the data a lot longer. And yeah, so this is what it takes to set up your server, and these are just a couple basic examples. So the next half of this is how do you set up your client? So I'm going to run step 6, and then in this repo, we have another example called client, which is just a very bare bone implementation of how do I run a query. And so the key libraries we're going to be using are React Apollo. And so over here, like when you start up this server, you're going to go and specify your client, and you're going to create this new Apollo client in which you have a URI. This URI should match whatever server you're having. So in this case, I have it to localhost 8000/GraphQL. But if you've deployed your server, you want to change that to the deployed URL. And then your Apollo provider, you want to provide the client. And then in here, you can like put in any components that make queries. And so we're going to jump into what all attendees does. And so all attendees is a component in which we have a query, and this is the GraphQL query we're running. So this GraphQL tag, GQL over here, specifies that this is a GraphQL query, which allows it to do some validation to say like, hey, this is in the right format. This is valid GraphQL, but it doesn't actually check it against the schema yet. And then, so when you run this query, there are 3 kind of states you can get back. You get your loading, your error, and your data. So while it's running information, it's going to show loading ... If it errors, it's going to make a sad face. And then if you actually get your data, what it's going to do is like actually fetch and parse this data and give you a list of all attendees. And so what this logic is doing is when you put in brackets, you can run JavaScript there. And so the query's response is always going to start with data. So you're going to say data.all attendees to get this field. And then you're going to look through every single one in that for loop and go and get that attendee's name and put it in a list element. So let's run this. So I'm going to close my server and first just go into my client and run npm install to install these packages, and then I can just run npm run start as soon as it's done. So in this case, my field is just going to say error sad face because my server isn't running, so it's not going to work. I'm going to go start up my server, and then when I reload this page, it's going to say loading. If you saw this, it's a loading for a millisecond as it was processing the request. And then it actually fetched the data and showed John and Bob as your 2 data points. And so cool things you can do is, this was our way of querying our backend. So let's say we are adding another attendee, and we go into attendee 3, and we add a 4th person. And when we refresh our page, it does reflect this data because we are changing the data in our server. And so we see all 4 attendee names. And so the reason like this works is like the Apollo framework kind of provides a way to make these queries. And some more of the queries like this, you can make mutations and change your data just directly through the UI and like hook up your front end to your backend this way. So yeah, that's an example of the plan. I'm gonna pause for any questions if there are any.
Yes, sorry. There are a couple. The first one is GraphQL only compatible with JavaScript and Golang?
No, there are tons of libraries. I've seen a couple for Rust, TypeScript, Python. People have built these libraries. I just showed the couple which I'm super familiar with. I will say I'm much more familiar with the Golang one and Thunder just because I work with that every day. But Apollo is, I think, more commonly used in open source and has the convenience of your front end and back end are both in JavaScript.
Awesome. And the other question is, the error messages I've gotten while using Apollo haven't been very helpful. Do you have any debugging tips? Because Stack Overflow is lacking as well.
Like, these might be very standard responses, but like running it with a debugger might be helpful. Also adding a lot of print statements, especially when those like error messages aren't really useful. And sometimes like they get not censored, but like you don't see the full stack trace because it's like clearing it out. So sometimes like adding those extra statements in the middle helps you figure out like where it is in your code. Yeah.
Awesome. Cool. Yeah, that's it for now. So we can go back to your presentation.
Cool. So we just did a bunch of like demoing of like how does it work. You should check out the repo. But I'm going to go back to the presentation and wait, can you still? Oh, you can't see my screen. Okay, can you see that?
Yes.
Okay, cool. So the next kind of questions to ask yourself is how does GraphQL scale? So these demos are built around like what is the fastest way to get a server running and start working with it. And one of the interesting questions to ask yourself is when you're using it at a company or when you have a lot of users, a lot more traffic, when users are asking for ridiculous amounts of data, like how do you scale this and how do you make sure like your GraphQL server still works? So I'm just going to go through a couple tactics with dealing with this and kind of going through like what do you deal with when you're working with this at a company. And so one of the biggest ones is pagination. So let's say you request all users and you have 1,000 users. They're not going to all fit on your page. And so it doesn't make sense to request your backend say, I want 1,000 users if you're not going to show it to your client. And so pagination says like, hey, you can specify pages on your client, but you can also specify what page of data you want to your server. And so it will just fetch like those 5 or 10 users or objects that you want to show on the page. And so the API for this is called a cursor API. So you can basically specify like combinations of like first and after. So if I say users first 2 after 5, it's going to look for my ID 5 and get the first 2 users, so 5 and 6. If I say like first 2 before 5, it's going to get me 3 and 4. I can also say like last 2. So like I can get the last 2 at the very end to like, if there are 100 users, like user 199. And so this cursor-based pagination just allows you to say like, hey, from this object, get like this many before or after, which allows you to specify like, this is the page I'm on, this is how many items are on the page. And like, if you want to do it with page numbers or infinite scroll, this API is kind of flexible with that. So this is one that's commonly used. One of the other really big ones is what happens when I have a lot of traffic. So for the, like when you're doing a project, like you just run a database and it's fine. But when you have a lot of users, you want to separate the fact that you have that one database can't handle all the load from all the requests from all the users. And so what you do is you say like, hey, I have a master node. And so if I'm running a mutation that's actually going to change my data, I want this to go to my master node. because that's actually going to change the data. And then your database can be in charge of replication. So it can create a copy of that same database. There'll be a little bit of lag in it copying over the data and making sure it's up to date. But any read requests, so GraphQL queries, can go to your replica. And you can kind of scale it out with more replicas depending on what your load is. And that's kind of how you deal with its scaling. I think one of the interesting things is that mutations are supposed to specify that you're changing data, but there is nothing to really enforce it to say like, hey, you can't, like someone can put a query and call it a mutation. And so when you create the primary and replica separation, this becomes really important of like, you don't want to run a mutation on your replica because it won't get replicated in the other cells. You want all mutations to be on your like primary or master database. And so that becomes like, not only is it good practice, but it really helps when you reach that point where you want to have multiple databases, and having that separation makes it easier to deal with. So yeah, that's a huge one that you see like start to happen at companies when you have a lot of users. The next really big one is batching. So I like to think about it as, let's say I'm going to go fetch all my users. And so it's going to make one DB request to go fetch all my users, and you're going to get 100 users. And then when you resolve device, that field only takes in a single user. And so it's going to say for this user, go get a related device, like if they're on an iPhone or Mac or things like that. And see like what their registered devices are. And so with that data structure, when you hit device, you're making 100 separate database requests to say, hey, for this user, fetch this device. And so that's fine at first, but eventually that hits a scalability limit of too many transactions going to your database. And so one thing you can do about this is batching, where you say like, hey, I'm going to get my 100 users, and in my devices field, I'm actually going to get all the users and make a single request to get all the users related devices. And simplifying it to one request, even if it's fetching all the same information, really helps with like the scalability of that database. Yeah, so that's what batching is. Also, I'm going through these topics pretty fast. Are there any questions so far?
Yes, there is one more. Is GraphQL good at caching? I'd imagine standard REST caches really well because it's so standard, but GraphQL queries vary a lot.
Yeah, so GraphQL has to cache it at a different level. Okay, I'm just gonna slide. But basically what you can do is say in memory, like if you're making a database request and you get the result and you say like, hey, for user one, this is my response, you can cache that in memory and say like, hey, store this. And the next time you make that same database request, go like use that in-memory cache to say, hey, I've already fetched this. I don't need to do it again. And so your caching tends to be more on like a data level of like on a database request or to another service, but not so much the entire query's response. So the caching looks a little different, but you can still take full advantage of caching. And there are features in Apollo that help make it a lot easier, like around that.
For now, that's all the questions we have. So yeah.
Cool. Yeah, that's caching. And then, yeah, the other like really interesting one is live queries. So this is the concept of you make a query and you have a bunch of users and someone changes your data, let's say adds a new field. In most cases, your page won't refresh. Like it won't show the new data until you refresh the page and it remakes the query. And so one of the interesting application needs is when you want it to be live. So you want to be subscribed to when the data changes. And when it does, you want to go requery it and show that information. And so this takes a little more setup to say like, okay, this is how I subscribe to this data source. But the second you do that, it allows you to just automatically recompute it. And so your dashboard always stays up to date. And then you can also do further optimizations. So let's say a single field changed in your like data. You can rerun the query and you can say, hey, this one field changed. I want to look at my previous response and my new response and find the difference between them. So see what fields changed and then go just only send the diff back to the client. And so this is another optimization where you can say, hey, I I want to minimize how much data I'm sending to the client and how much it's changing and reloading. And so I can only send the fields that I care about. And so this is a really cool optimization that you tend to want depending on what your data needs are. But yeah. So those are kind of some of the big topics of scalability of GraphQL. But for the context of how to actually use this, the next big question that you go from here is, what type of database do I use? So if you notice in all my examples, I was just storing it in a variable in memory. But that's not going to persist as I close my app. And so to kind of deal with that, you'd want to use a database. And so the questions to ask yourself when you are making this decision are, what's the structure of your data? So the two big ones, one of the big choices is SQL versus NoSQL. And the next one to ask is, what is the relationship between the different data I want to represent? And so with SQL, what it means is you can kind of think of it as a table with columns and rows. So for the examples I had before, you can have like a user table, and your columns can be like your ID, your name, and your email. And these are all columns in the table, and every row is your entry. So like the first row would be like ID1 John, second row is like ID2 Bob. And so when your data is structured like that, you can run a SQL query that looks like this example below, where you can say select ID, name, and email from users, where ID is 1. And it'll just fetch exactly the fields you ask for. And then if you want to represent relationships between two databases, you can join them. And so you can combine them based on a single ID and look at the relationship between them and fetch whatever information you need. But like before you make the decision to use it, one of the restrictions is like SQL will say like, hey, you have to define these columns, and you do have to fill it out in some form. So it's a little more rigid in saying like, these are your columns and this is how your data is structured, and you're enforcing that, which works in some cases, and on some application use cases, it doesn't make as much sense. So NoSQL is the opposite, where you can kind of think of it as a JSON blob, where you can store large volumes of data and they don't necessarily have to match a certain structure. So the schema is more flexible. So an example to kind of contextualize this is, let's say you have a bunch of users. Some of them are HackIllinois attendees, so I want to add like information about their teammates, versus if someone's a mentor, you want to know like who's on their team, and your data tends to be structured a little differently because those are inherently different objects. They're both users or people registered, but like the fields are different. And so an example of this would be like you've John, who's a mentor and has a mentor secret key, and you've John, who is an attendee, who has an attendee secret key and a bunch of teammates. And so these data structures look different, but they can both be stored as users. And you get a bit more flexibility in saying like, hey, my schema can look different. I can add new fields and structure relationships differently. So like my teammates can be other attendees, versus in SQL, like that might take multiple queries to actually resolve, or like a bunch of joins. And so depending on what your data needs are, you can kind of figure out what you want to do. But whatever you decide, I'd say find a hosted database for it, so it can set up the cluster for you and just give you a URI, so you can go query it and add information and query information and get things. One of my favorites to use is MongoDB. And so I posted a link to a hosted version of it, where you can start up a cluster, get that URI, and just start making queries directly to it. This is a NoSQL one. You can use MySQL for SQL and just kind of explore what your data is and what type of database fits you. But yeah, I'd say beyond this, like play around with the framework. I went through it on a very like high level and just a few basic examples of how does it work. But the best way to learn is to write your own objects, fields, queries, mutations, and get familiar with it and see what works and what doesn't work and build your applications. But yeah, thanks for listening. And if there are any questions.
Awesome. Thank you so much. We have one more question. What are the benefits of having a more structured schema?
Yeah, so you get some type safety off the bat of saying like, hey, my data is always going to look like this and have these fields, and you can feel more confident that it's going to be there, versus with NoSQL, you do have to check of like, hey, does this field exist before I try to get information out of it? Yeah, I think that's probably one of the biggest ones. Okay.
Awesome.
Yeah.
We're good with questions. So Raghav, you want to take it from here?
Yeah, for sure. Thanks everybody for obviously, coming out. We hope you enjoyed the workshop, got a lot from it. As with all of our workshops, we will be uploading this one also to our YouTube channel. So feel free to follow along and watch it later. Right now in the chat, I'm actually posting the link to a form, which you can use to kind of enter yourself in a giveaway for a Grubhub gift card, actually, for those of you who kind of stayed till the end. I've posted the form link and the password right there. Also stay tuned for the Optum Q&A, where you'll kind of get to network with Optum recruiters, talk to people currently at Optum about their experiences, as well as internship and co-op opportunities that they might have. That'll be at 2 p.m. Central. But until then, thank you all for tuning in, and we'll come back to you with workshops in the future. I think that's about it. Thanks, everyone. We're good.